Very good morning, dear children. Let us start our today's class with a prayer. God, grant me the serenity to accept the things I cannot change, courage to change the things I can, and the wisdom to know the difference. Amen. Dear children, for today we are going to see the 10th unit of your book, Matter Around Us, which is the first lesson in chemistry, the 9th standard. By learning this lesson, you will be able to classify the substances as element, compound, and mixture based on their chemical composition. Also, you can group mixtures as homogeneous and heterogeneous. You can easily identify suitable method to separate components of a mixture. You can classify solution based on the size of the solute particles and compare the true solution, colloids and suspensions based on their properties. We can able to differentiate colloids based on the nature of depression phase and depression medium. You can compare emulsion, and also you can discuss some important examples and uses of colloids. Let's move on to the lesson. We use the term matter to cover all substances and materials from which the universe is composed. Matter is everything around us. The air we breathe, the food we eat, the pen we write, clouds, stones, plants, animals, a drop of water or a grain of sand, everything is matter. Samples of any of these materials have two properties in common. That is, they have mass and they occupy space. The first picture shows you every object will have mass. And the second picture shows you that it may be a solid, gas or liquid, it occupies some space. So what is the definition for matter? We can define matter as anything that has mass and occupies space can be called as matter. This is the definition for matter. Matter is anything that has mass and occupies space. So, in your class 8, you studied the same topic but in a different approach. How you differentiate matter? It is based on their physical property. It may be solid, liquid, gas. So based on their physical property, you classify matter in your 8th standard. But in 9th standard, based on the chemical composition, we are going to classify matters. So it can be classified into pure substance and mixture. From the point of view of chemistry, pure substances are those who contain only one kind of particle, where impure substances, that is called mixture, it contains more than one kind of particle. So the same kind of particle will result in pure substance. If matter consists of more than one kind of particles, means it is called as impure substances. It is nothing but mixture. So there is a flow chart that shows you about pure substance and mixture. You here at this point, you also have to know that sunlight, sound, force, these are all the things around you. But these things will not come under matter because they are simply energy. They doesn't have any mass and they will not occupy any space. See, the sunlight transfer from sun to earth in the free space, vacuum. So it doesn't occupy space and it doesn't have mass. So they will not be categorized as matter. They are all energy. About that things and their properties you will be learning in your further classes, in higher classes. Let's move on to the flow chart. This flow chart shows you that the different types of matter, pure substances and impure substances, that is mixture. The pure substance can be further classified as elements and compounds, and impure substances can be classified as homogeneous mixture and heterogeneous mixture. Let's know about each type detailedly. First, Let's see what are elements. Most of you may be interested in music and some of you may know how it is composed. You know the tune Sari, Gama, Bada, Nisa. Yes, thus the building blocks of music are the musical notes. Likewise, all substances on earth are made up of certain simple substances called elements. Plants, cats, apples, rocks, cars, and even our bodies contain elements. Thus, elements are the building blocks of material. So, what are elements? Elements are the building blocks of all materials. So, in the modern period, in the modern periodic table, there are 118 elements known today. 92 of which are naturally occurring, while the remaining 26 have been artificially created. But from these 118 elements, crores of compounds are formed, some naturally occurring and some artificial. So, how many elements are there totally? There are 118 elements. There are 118 elements. So, here Robert Boyle used the name element. The meaning, the definition for element is now follows. Element for any substance that can be broken down further into a simple substance. That cannot be broken down further into a simpler substances. So, elements cannot be broken down into a simpler substances. This definition can be extended to include the fact that each element is made up of only one kind of atom. For example, aluminium is an element. So, it is made up of only aluminium atoms. Similarly, any chemical substances such as oxygen is made up of only oxygen atoms. Nitrogen is made up of only nitrogen atom. Iron is made up of only iron atoms. Okay, so these are all elements. So, here there is a definition, there was definitions given to you about atoms and molecules. What are atoms? These are very important. Definition, question and answer. The smallest unit of an element which may or may not have an independent existence but always takes part in a chemical reaction is called atom. What are molecules? The smallest unit of a pure substance which always exists independently and can retain physical and chemical properties of that substance is called a molecule. For example, hydrogen molecule consists of two hydrogen atoms. If I want to write hydrogen atom means I have to write H alone. If I write H suffix 2 means it indicates hydrogen molecule. So, atom means hydrogen H. Hydrogen molecule means H2. Similarly, for oxygen. Oxygen atom O, oxygen molecule O2. These things will be you learning in the further classes. Don't worry about this. So, all elements can be classified according to the various properties. So, a simple way to do this classification is we can classify elements as metals, metalloids, non-metals. In the previous we have seen that 118 elements are there. So, in that periodic table itself they will classify, shows the difference in the by differentiating its colors, metals, metalloids and non-metals. So, example for these metals and metalloids and non-metals from the periodic table has been given in your textbook. Copper, chromium, gold, mercury are example for metal, and boron, silicon, germanium, arsenic are examples for metalloids. Carbon, oxygen, neon, chlorine are examples for non-metals. So, I hope you understand what are elements. Let's move on to the concept of compound. When two or more elements combine chemically to form a new substance, the new substance is now called as compound. For example, cane sugar is made up of 3 elements of carbon, hydrogen and oxygen. So, the cane sugar, or simply if you want to say, it is glucose, nothing but glucose. Glucose is made up of 3 elements, namely carbon, hydrogen and oxygen. So, elements are carbon, hydrogen, oxygen. The glucose which is formed by carbon, hydrogen, oxygen is called as compound because they are in a particular proportion. That proportion is known as chemical formula, and the cane sugar's chemical formula is C12H22O11. So 12 carbon elements, 22 hydrogen elements and 11 oxygen elements combine together to form glucose. A compound has properties that are different from those of the element from which it is made. It may or may not have the same property as the element. Common salt, also known as the sodium chloride, that is nothing but NaCl. NaCl is nothing but common salt. It is added to give taste to a food. So it's a compound made up of metal called sodium and a non-metal called chlorine. Sodium, metal, chlorine, non-metal. They combine together form table salt NaCl. Okay. In our day-to-day life, number of compounds are used for many useful purposes. For example, go and read do you know. In that do you know, compounds of phosphorus, nitrogen, potassium are used in fertilizer. Silicon compounds are of immense importance in the computer industry. Compounds of fluorine are used in our toothpaste. Compounds of fluorine are used in our toothpaste and they strengthen our teeth. Let's know the difference between elements and compounds as in your textbook. Elements made up of only one kind of atom, whereas compounds made up of more than one kind of atom. The smallest particle that retains all its properties in an atom is called as element. The smallest particle that retains all its property is a molecule. It cannot be broken down into simpler substances. It can be broken down into simpler substances by chemical methods. It is not easily breakable, but chemical methods we can break them. Okay. Now let's see what are mixture. A mixture is an impure substance. It contains two or more kind of element or compounds or both physically mixed together in any ratio. See, in the previous case compound we have seen that two or more elements combine together to form new substances. But it should be combined chemically in the case of compound. In the case of mixture, two or more elements can be combined together by physically. There is a difference between physical composition and chemical composition. For example, tap water is a mixture of water and some dissolved salts. Lemonade is a mixture of lemon juice, sugar and water. So if I want to prepare lemonade with any ratio, if I want more sugar, I can add more sugar. If I don't want sugar, I can reduce the quantity of sugar. So there is no proper proportion. Air is a mixture of nitrogen, oxygen, carbon dioxide, water vapor and other gases. Soil is a mixture of clay, sand and various salts. Milk, ice cream, rock salt, tea, smoke, wood, sea water, blood, toothpaste and paint are some other examples of mixtures, alloys or mixtures of metals. Here another important mixture used in our daily life has been shown, that is LPG. LPG is nothing but liquid petroleum gas. It is highly inflammable hydrocarbon gas. It contains mixture of butane and propane gases. So LPG liquefied through pressurization and it is used for heating, cooking, auto fuel, etc. So I have already told you the definition for compound and mixture sounds together, but it is not actually same. So let's see the difference between mixture and compound. It contains two or more substances in a mixture. Compound is a single substance. The constituent may be present in any proportion in a mixture, but the constituents are present in definite proportion in a compound. They show the properties of their constituents. That is, the mixture shows the properties of the constituents. In a compound, they do not show the properties of the constituent element because it is a new product. It has its own property. The compounds may be separated easily by physical method. The constituents can only be separated by one or more chemical reactions. It can be separated by one or more chemical reactions. So you cannot separate them physically if it is a compound. Here in your textbook, in activity 3, they have shown you a beautiful example which helps you to distinguish between mixture and compound physically. I would like to show some slides regarding this. Let's see. See the activity 3 in your textbook. You have to take some powdered iron fillings, iron, and you have to take sulfur. But you have to mix both of them. The grey color shows you the mixture of iron filling and sulfur. Iron filling is in dark color and sulfur is in yellow color. You mix both of them and get the center one, that is grey color. It is a mixture of iron filling and sulfur. It doesn't have a new name. It is a mixture of iron filling and sulfur. And divide the mixture into two equal halves. Keep the first half of the mixture as it is, but heat the second half of the mixture. So this middle plate, grey color matter is divided into two halves. One half is kept as it is, another half is going to be heated. On heating, you will get a black brittle compound. That is called iron to sulfide. Iron to sulfide. See what happened to the first thing. Let's see, this is the result of the mixture, that is iron filling and the sulfur. Its appearance should be, the table shows, its appearance should be dirty yellow powder. And what is the effect? If I use a magnet, the iron powder is attracted towards the magnet. We can easily separate the iron and the sulfur by means of physical activity called using magnet. By physical means, we can separate this mixture, iron filling and the sulfur. But I heat these two things, I get iron sulfide as a compound. This one thing, that solid thing you can see, no, that is a compound. So if I use a magnet again towards, I bring the magnet again towards that iron to sulfide, what happens? No effect can be found. The iron filling, the magnet doesn't attract anything. It attracts nothing. Okay, so what is the matter? A compound produces a new product. It will not have the property of its property of the iron and sulfur. Okay, it is clear. Now let's see the types of mixture. Most of the substances that we use in our daily life are mixtures. In some, we will be able to see the components with our naked eyes, but in most others, the different components are not visible. Based on this, mixture can be classified as below. So we can see some mixtures with using naked eye. We cannot distinguish the constituents of the mixture in many cases. So based on this property, visibility, we can distinguish the mixture into two types as heterogeneous and homogeneous mixture. What are homogeneous mixture? Homogeneous mixtures are further divided as true solutions and alloy. Heterogeneous mixtures can be classified as suspensions and colloid. First, homogeneous mixture. Let's see the homogeneous mixture. A mixture in which the components cannot be seen separately is called homogeneous mixture. So you cannot see the components separately. It is called as homogeneous mixture. It has a uniform composition and every part of the mixture has the same property. See the tap water, milk, air, ice cream, sugar syrup, ink, steel, bronze and salt solution. These are all very good examples for homogeneous mixture, because you cannot distinguish, you cannot separate any constituents from any part of the mixture. All the part of that mixture will remain same. A mixture in which the component can be seen separately. Cannot be seen means it is homogeneous. Can be seen means it is heterogeneous mixture. It does not have a uniform composition and properties. See soil, a mixture of iodine and common salt. If you mix the common salt with iodine separately, the salt which is available at shops will not come under this category. You are going to mix the iodine with the common salt. A mixture of sugar and sand, a mixture of oil and water, a mixture of sulfur and iron fillings, and a mixture of milk and cereals are heterogeneous. So you can easily distinguish the components of the mixture and the proportion will not be same everywhere. So, there are different methods followed nowadays to separate these mixtures. Many mixtures contain useful substances mixed with unwanted materials. So, to obtain useful substances from the unwanted materials, we have to remove the unwanted materials. So, chemists often have to separate them from the impurities. That unwanted materials are commonly called as impurities. The choice of a particular method to separate components of a mixture will depend on the properties of the components of the mixture as well as their physical states. So, let's see about supplementation. So, certain solid substances when heated change directly from solid to gaseous state without attaining liquid state, because as you all know, what is the level of states? A solid turns to liquid, then it turns to gas, as in the case of water. But few materials, few elements will change directly from solid to gaseous state. Okay. The vapors when cooled give back to the solid substances. This process is known as supplementation. I repeat the definition of supplementation again. Certain solid substances when heated change directly from solid to gaseous state without attaining liquid state. The vapors when cooled give back the solid state substances. This process is known as supplementation. Example for supplementations are iodine, camphor, ammonium chloride, etc. So, here using the supplementation process, we are going to separate the wanted elements from the impurities. The powdered mixture of ammonium chloride and sand is taken in a china dish and covered with a sheet. Okay, so it is covered with a sheet. An inverted funnel, this is the inverted funnel because it has a open, is placed over the sheet. The open end of the stem of the funnel is closed using the cotton. You can see the cotton plug here. So, the open end of the funnel is now closed. Using cotton wool and the china dish is heated now. It is under heating. The pure vapors of the solid pass through the holes in the sheets and condense on the inner side. Here you can see the condensed particle. Inner side of the funnel. The non-volatile impurities remain in the china dish. Okay. So, the solidified ammonium chloride is here. Here you can see the vapor of ammonium chloride. So, using this method, we can remove the impurities along with the ammonium chloride salt, because the impurities cannot have the process called supplementation. Okay. Next we move on to centrifugation. It is another process. Centrifugation is the process by which fine insoluble solids from a solid liquid mixture can be separated in a machine called a centrifuge. A centrifuge rotates at a very high speed. So, this is the machine centrifuge. See, before centrifugation, the solid particles are everywhere along with the liquid particle. So, after centrifugation, the solid particles comes down and the liquids can be separated. Solid can be separated. Okay. A centrifuge rotates at a very high speed. On being rotated by centrifugal force, the heavier solid particles move down and the lighter liquid remains at the top. In milk dairies, centrifugation is used to separate cream from milk. In washing machine, this principle is used to squeeze out water from the wet clothes. Centrifugation is also used in pathological laboratories to separate blood cells from a blood sample. Next, we need to see about solvent extraction method. So, this is solvent extraction method. It is used in the case of two immiscible liquid can be separated by solvent extraction method. This method works on the principle of difference in solubility of two immiscible liquids in a suitable solvent. For example, mixture of water and oil can be separated using a separating funnel. So, solvent extraction method is used in pharmaceutical and petroleum industry, because in petroleum industry not only petrol is obtained at various levels, various pressure level and heat level, various substances are obtained. So this method, solvent extraction method, is used in petroleum industry. So this is how this solvent extraction works. Solvent extraction is an old practice done for years. It is the main process in perfume development, and it is also used to obtain dyes from various sources also. Next we are going to see about simple distillation. Distillation is a process of obtaining pure liquid from a solution. It is actually a combination of evaporation and condensation. That is, distillation is equal to evaporation plus condensation. In this method, a solution is heated in order to vaporize the liquid. The vapor of the liquid on cooling condenses into pure liquid. For example, sea water in many countries is converted into drinking water by this distillation method. This method is also used to separate two liquids whose boiling points differ more than 25 Kelvin. A distillation flask is used with a water condenser. So this is a pink color one. This is the distillation flask. It is used with water condenser. A thermometer is introduced into the distillation flask. You can see the thermometer at the top. So the thermometer is introduced into the distillation flask through an one-hole stopper. The bulb of the thermometer should be slightly below the side tube. The brackish water, that is sea water, to be distilled is taken in the distillation flask and heated for boiling. The pure water vapor passed through the inner tube of the condenser. This is condenser. So after that, this water steam is cooled down, and you can get a pure water. Here you receive the pure water. The vapors on cooling condense into pure water, that is distilled water, and are collected in a receiver. The salt are left behind the flask as a residue. Here in the flask itself you can get the salts as a residue. Next we are going to see about fractional distillation. To separate two or more miscible liquids which do not differ much in their boiling point, that is, difference in boiling points is less than 25 Kelvin, fractional distillation is employed. Fractional distillation is used in petrochemical industry to obtain different fractions of petroleum to separate the different gases from air. So this is the picture which shows you fractional distillation. It is used where two liquids or more than two liquids combined together which has the boiling point less than 25 Kelvin. Next we are going to see about chromatography. Before we discuss the technique, we will take a look at the difference between the two important terms, absorption and adsorption. Adsorption is the process in which the particles of a substance is concentrated only at the surface of another substance. Absorption is the process in which the substance is uniformly distributed throughout the bulk of another substance. For example, when a chalk stick is dipped in ink, the surface retains the color of the ink due to absorption of colored molecules, while the solvent of the ink goes deeper into the stick due to absorption. Hence, on breaking the chalk stick, it is found to be white from inside. Now move on to chromatography. Chromatography is also a separation technique. It is used to separate different components of a mixture based on their different solubilities in the same solvent. There are several types of chromatography based on the above basic principles. The simple type is paper chromatography, which is shown in your textbook. I have given you the clear picture of this paper chromatography. This method is used to separate the different colored dyes in a sample of ink. A spot of the ink, example black ink, is put on a piece of chromatography paper. This is chromatography paper. This paper is then set in a suitable solvent as shown in the figure 10.10. The black ink separates into its constituent dyes. As the solvent moves up the paper, the dyes are carried with it and begin to separate. They separate because they have different solubility in the solvent and are adsorbed to different extents by the chromatography paper. The chromatogram shows that the black ink contains 3 dyes, as in your book. In page number 117 in your textbook, they have shown you types of mixture. So what are the components of mixture in the next column, and the methods of separation for particular mixture type has been given in the table. So you go through the table, it may be important in the exam point of view. So let's move on to the another topic. Next topic, solution. A solution is a homogeneous mixture of 2 or more substances. In a solution, the component present is lesser amount by weight is called solute, and the component present in the larger amount by weight is called solvent. In short, a solution can be represented as follows: solute plus solvent gives solution. Example, salt is a solute and water is a solvent, which results in salt solution. Let's see the types of solution. Based on the particle size of the solute and solution are divided into 3 types. Namely, true solution, colloidal solution and suspension. So, we know about true solution. Let's move on to colloidal solution. A colloidal solution is a heterogeneous system consists of a dispersed phase and a dispersion medium. Dispersed phase or the dispersion medium can be solid, liquid or gas. There are 8 different combinations possible in this colloidal solution. Table 10.4 shows you the classification of colloids based on the physical state of dispersion phase and dispersion medium. Here I shows the JF for the important definition. Brownian movement. When colloidal solution are viewed under powerful microscope, it can be seen that colloided particles are moving constantly and rapidly in zigzag direction, which is shown as I show you, which is shown here. Zigzag direction. The Brownian movement of a colloidal particles is due to the unbalanced bombardment of the particles by the molecules of dispersion medium. So, the colloidal particles will not move in a proper direction. It moves randomly in a zigzag way. So, which is shown as in the slide. Okay. I hope you understand this concept, Brownian movement. You might have seen this scenery. Also, you will enjoy to see this scenery. What is this? Tyndall observed that when a strong beam of light is focused on a colloidal solution, the path of the beam becomes visible. See as this one. The path of the beam is visible not in pure substances. The first glass is a pure substance and the second glass is a colloid. Okay. So, colloidal solution, the path is visible. This phenomenon is known as Tyndall effect, and the illuminated path is called Tyndall cone. This phenomenon is not observed in the case of true solution. The reason I have shown in this slide. The reason is not in your textbook, but I have shown in the slide. The particles in a true solution do not scatter light. Due to this, we cannot see the path of the beam of light inside the true solution. But the particles in a colloidal solution is large enough to scatter the light. So, due to this, you can see the path of the beam of light inside the colloidal solution. So, this is the reason it may be asked in your 2-mark question answer. Okay. Next topic is emulsion. An emulsion is a colloid of two or more immiscible liquid where one liquid is dispersed in another liquid. This means one type of liquid particle gets scattered in another liquid. In other words, an emulsion is a special type of mixture made by combining two liquids that normally don't mix. The word emulsion comes from the Latin word meaning to milk. The process of turning a liquid mixture into an emulsion is called emulsification. Milk, butter, cream, egg, yolk, paints, cough syrup, facial creams, pesticides, etc. are some common example of emulsions. So up to this I am going to wind up the lesson. I hope you all understand. God bless you. All the best.